Cool. Yeah, well, thanks everyone. Hi, thanks for joining today's Golang in London. Obviously, hope you're all safe and well. Great talk today from Aden Fraser, who is technical lead of the operations team at Flyt. We'll be recording this event and posting it to YouTube afterwards, so please feel free to share it with anyone you know who wasn't able to attend. Sorry. So just by way of a quick introduction, Rory here at Oliver Bernard. We're a tech recruitment company, but we also run a number of community events like this one. So you can actually see all our events on our website. The link's posted on the main meetup group. So please have a look at that after this. Could be another few things coming up of interest. I specialise in the Go market, which is obviously why I've been organising these. So one quick thing before we get started, I've posted a link in this event page actually. With a link to a Just Giving page on it. All the money from that goes to the National Emergencies Trust, who, in partnership with the Red Cross, providing support and distributing funds to loads of local charities. So any donations would be greatly appreciated. But yeah, let's get to it. So as I mentioned, we've got Aden Fraser from Flyt today, who'll be giving a great talk, migrating from Monolith to Event-Driven Microservices in Go. So I'll be explaining everything around that, challenges, considerations, how they can be successfully achieved, and everything like that. I know we've got a lot of people on the call from a range of backgrounds, a lot of people from strong Go backgrounds, a lot of people from different technical backgrounds. So I think it could be of interest to a lot of people. The talk will last around 35 minutes or so. And then we've got some time for some Q&A at the end, which Ada will explain a bit more as he goes through. So that's all from my side. I'll keep admitting people as they come, but yeah, over to you, Ada.
That's great. Thanks for that introduction. Thanks all for attending this evening. A bit of a weird time for all of us attending remote meetups, but let's jump straight in. Hopefully we'll have a handful more participants joining us very shortly. So a bit of an introduction. This talk isn't about me, but let's jump in and be clear. Hopefully it will set the scene a bit. This is me, I'm Aden, and this is my lockdown haircut, thanks to my beard trimmers. I'm a technical lead at Flyt, and we're a subsidiary of the Just Eat group. So for those of you who order takeaway, you should be familiar. I also undertake a handful of other technical ventures. I do some consultancy, and I work with a few different startups. Today's my first talk. Obviously, we're all here remotely in these weird and uncertain times, and you're here to hear me talk about the challenges that we've undertaken at Flyt, migrating from a historical PHP monolith built in Slim framework to Go-based microservices in an event-driven manner. Worth noting, opinions here are my own, and they're not of my employer, of Flyt, or the Just Eat group. Just need to state that. So, kicking off, if I can move to the next slide, which would be really beneficial. Just a moment, there we go. A little bit of a warm up. I'm very aware that presenting remotely has its challenges. I can't really get a feel for the audience. I can't see a lot of your faces today. Webcams aren't on, but I wanted to make this experience engaging. So I've set up a Slido link, and if possible, we'll go through and we'll begin by hopefully a handful of you joining the Slido link at slido.com. If you enter the key of K925, we'll just run a trial exercise here to see who has ordered takeaway from Just Eat. It'd be really nice to get everyone engaged and to sort of see how that's looking. I can see one person's already jumped in already. We'll run through this for the next 30 seconds or so, just to let everyone get set up. Throughout this talk, there will be a handful of other questions, and at the end, we'll have a Q&A. It'd be really nice to get as much engagement as possible. You can see the folks are starting to come in now at quite a nice rate. Quite a lot of people order from Just Eat. Similarly, I suspect those of you who don't probably order from competitors such as Deliveroo or Uber Eats. I heard some agreement there in the background. Very level pegging. Great stuff. Well, I'm going to give it another 5 or 10 seconds and then we'll move on. This wasn't an important question. It was just to set the scene and get everyone familiar. We'll move on now. So let's get started. If I can move on. Sorry, some technical issues. How do I move to the next slide? Oh my. Hey, we got there. That was just a test. Let's actually crack on with the real meat of the talk. So monolith to microservices. Let me give you a bit of a background, a bit of a history about Flyt and microservices. So Flyt was founded about 6 years ago, and it evolved as a scrappy startup that served to do one business function. And that was a product called Pay at Table. And at the time, everything was built in PHP as a monolith. And over the course of Flyt's history, obviously that evolved. When you start out with a monolith, there are obvious advantages. You've got the ability to move fast on a single tech stack. Changes are super easy to make. And if you need to make any complex changes, they're actually relatively straightforward to test. Deploying a monolith is also incredibly straightforward. If you design it in a stateless manner, it's really easy to scale horizontally without very many concerns. And you can scale your engineering departments around them as well. And then over time, your company begins to grow. Your monolith grows, and you begin to add more business functions. And at Flyt, what that looked like was a handful of new product capabilities, and actually something that's very common in startups, that is a pivot towards a slightly different direction. Flyt had started out serving bricks and mortar restaurants with technologies such as Pay at Table, but it actually moved progressively into the delivery space. So the monolith had grown to offer more of these capabilities. And over time, there were always more being added. Some from customer feedback, getting a lot of questions. Sorry. Some, over time, obviously there's lots of unused functionality being introduced into the code base. Customers make requests, you make changes, those are left unused. Technical debt is gradually being introduced. In the case of Flyt, it can actually be a lot. You've got lots of individuals working on it. You start out as a very small team, maybe with a handful of engineers. Your company grows, the number of your customers grows, the number of engineers in your team grow as well. So with these engineers all working on it together, there is the opportunity for them to step on each other's toes. But overall, inter-team communication does keep things moving. And that's good. You can continue to grow, and the company remains moving at pace. And then a bit more time passes, and fires start to burn. You start to run into problems with scalability. You start to run into production incidents that seem to last hours, not minutes. And you seem to be firefighting a lot more. And this makes everybody a bit uneasy. And when you've extinguished those fires, the teams start to move more slowly. They're starting to move more slowly because they're a bit more aware of the risks that your monolith platform has. And you're moving really slowly when it comes to innovation. Innovation in your unwieldy monolith has become really, really hard. It's become really hard because over time, more and more code's been added, and it's tightly coupled together. And every small change you want to make causes regression elsewhere. This has really started to plague Flyt. And Flyt had really slowed down in the way that it could innovate. And that's not all. Obviously, innovation suffers, but culture suffers too. Engineers set out their day in a way that they want to be productive. They want to take on new tasks. They want to build product improvements. They want to feel challenged. With a monolith, this starts to prohibit the rate that they can do that. And instead, they're firefighting bugs, and they're undertaking technical problems that actually they would have preferred not to have existed. Individuals don't really feel like their careers are progressing in the right direction as they go around and deal with this archaic PHP monolith. And they start to question whether there's something else out there for them. Is this really the right company? Because when I set out for this, it was a fast and rapid moving startup. And now we're a large organization that isn't willing to deploy on a Friday because of the risk. That doesn't sound like the company I signed up for. All the individuals in the company begin to drown under the pain of that monolith. Before we move on, I'd really like to get a feel, who here has experienced a monolith growing unwieldy in this manner? I'm sure some of you have in your current company. Maybe some of you have in a previous company. It's entirely possible that none of you have really encountered this. Lucky you. But the votes are coming in, and it certainly feels to me like this is quite a common engineering problem. Nobody yet has replied with a no, but I'm sure there'll be one or two, that's for sure. The thing with the monolith growing unwieldy like this is you don't really expect it. There's not a day where you say, this has grown out of control. The monolith evolves over a course of a long period of time. And when it presents itself, it's very hard to step back and work out what's next. So we're left thinking, how do we get here? How do we fix this? And how do we avoid jumping to a solution? Because we felt a lot of pain from our monolith, and we want to jump towards the next best thing. We want to move to a solution. But just jumping at the first solution will not leave us as happy as these people in this background, that's for sure. We need to take a step back, and we need to consider a blank canvas as to what our real problems are right now. What is the definition of fixed? What are the problems that our monolith has, and how do we move forward? What do we really want? What do we need? And more importantly, what did we miss from the good old days where we were able to move in a fast and scrappy startup manner? So we came up with a handful of requirements, and those were things like being able to move fast again. No longer will we be in a position where changes that should take hours take days. We want to be able to move fast and innovate quickly. The market's changing, competitors are moving quickly. Our customers expect us to be in a position where we can make rapid change. And frankly, making rapid change on our monolith was causing us to break things repeatedly. There was always regression. And subsequently, we needed to be in a position where we could reduce that risk of deploying at any time of day where we aren't going to cause major outages. We wanted to be able to reduce the risk of the way that our monolith actually served our customers, so it's not going to cause a reputational risk to the FTSE 100 company that now owns us. And we wanted to be in a position where our teams could be a bit more autonomous. When we had one team at Flyt, people could move quickly. Even with a handful of teams, you can move fairly fast with communication across teams. But as the company had grown to a global company split across multiple time zones, having teams having to tightly communicate with each other to reduce overlap was becoming really challenging. And that really brings me on to Conway's law. And I've stolen a diagram here from Sketchplanations because this diagram sums up exactly the direction of where we want it to be better than I could describe. Conway's law, paraphrased, is the structure of software will mirror the structure of the organization that built it. Small distributed teams are more likely to produce software that is modular and service-oriented, whereas large co-located teams are likely to produce a monolith. Flyt had started out as a small company in one office, and then it had grown and it had added more teams and more engineers, and that monolith had grown with it. But Flyt was now in a position where it had multiple distributed teams, thanks to some rework in the way that the organization was structured, but yet we were still dealing with the after effects of a monolith that had grown over 6 years. And we really wanted to be in a position where our teams actually could own services and own capabilities rather than having to all muddle over this one thing. So we had a look around. How are other companies overcoming these problems? And what we found was loads of buzzwords. It was buzzword bingo. Agile, decoupled, distributed, service-oriented, event-driven, blockchain. How was blockchain going to solve the problems of our monolith? It wasn't. But one thing, and we were predisposed to this already, but it had to be confirmed. The one thing that was really obvious, and it was the real light bulb of all of the buzzwords, was microservices. All the big companies were doing it, from eBay to Uber to Netflix to Google, and many, many more. They were all up there and they were doing microservices for reasons to solve problems that we had. So before we move on, who here is working in an organization right now that is using microservices? Perhaps that's exclusively, and you've managed to get rid of your monolith, or maybe you've never had one, or perhaps you're in a position where you have a microservices, but you're also getting rid of a monolith. I'm sure there's a handful of you who are in a position where you've never actually worked with microservices yet. So this might be unveiling some new information and some new challenges for you. Looks like we've got 21 votes so far. Seems like everyone's still got a monolith. That's certainly the case with Flyt. We've migrated a lot of capability from our monolith to our new event-driven architecture, but I couldn't say that we're there yet. We certainly haven't strangled that monolith just yet. Very interesting. So moving on, we had to make a decision as to whether we really would use microservices, and why would we? Well, obviously we're going to make a change for some reasons, and those reasons were the benefits. And the benefits was everything we set out for. We wanted to be able to move faster. We wanted teams to move in a more autonomous manner. We wanted to be in a position where we could innovate but reduce risk. And doing that in a monolith just was no longer proving realistic. Whereas being able to innovate by changing or introducing one new service shouldn't impact the other ones, at least in theory. Now, there are obviously a handful of drawbacks that we'd come across during our research. Drawbacks such as the high cost of ownership of having a service-oriented architecture, the drawback of having multiple magnitudes more of complexity by having boundary issues. Having one monolith, it's easy to cross-communicate between different domains and different namespaces. But once you introduce services with boundaries, you're introducing a lot more complexity, a lot more risk. And that's certainly something that we were very aware of from the outset. And there are other drawbacks too, things like standards, things like service ownership, but we're going to probably run into those later. The most important thing for us at this point was how do we overcome these drawbacks to help us weigh up whether the argument for microservices was compelling. And we figured that we could overcome a lot of these drawbacks with some careful planning and picking out the right tech stack, and ensuring that through investing our time in consistent tooling that we can actually overcome drawbacks such as having the right monitoring for our services. So was the argument compelling? It was. So we started to move forward, but we didn't jump in. We had some prerequisites, and these prerequisites were really important, and we would not have ended up where we got to today without them. We wanted to be able to provision in minutes and not hours. It took hours to get set up for someone onboarding into a monolith, and we didn't want to repeat that. We wanted to move faster, not slower. And we also wanted to be able to deploy in minutes, not hours. We wanted to say goodbye to those 30-minute CI pipelines on a pull request, which would then be merged. And then we'd see another 30-minute CI pipeline run on the master branch, because that was no good for us. And we wanted out-of-the-box consistent monitoring. There's no point going from one monolith to dozens of services if you don't have trust in them and you can't ensure that they're all healthy and all online. And we didn't want to be in a position where services were built with inconsistent monitoring, because that's just as bad as no monitoring at all. And most importantly, we were really wanting something that was consistent around tooling. We didn't want different tooling across different teams, because that meant that as individuals churn and as individuals move between different teams, it'd be really hard and there'd be a lot of cognitive friction of picking up and changing the way things work. We wanted some levels of consistency, and we wanted to introduce that by building out our own layers of abstraction, so that when we communicated with S3 or with Dynamo or with our event bus, it could be done in a consistent manner, and it was predictable. And the last prerequisite was for us to be event-driven. We certainly didn't want to replace a monolith with a bunch of microservices that communicated to each other using point-to-point. Why? Well, because every service that needs to communicate with another service then has to have awareness of it. And then we're coupling all the services back together, and we're never going to reap any of those rewards of being decoupled and decentralized. So we had to take an event-driven approach. One thing wasn't yet clear though. Size. What is a microservice? Is it a microservice or is it a macroservice? How big should the services that we design actually be? And we looked around and we just couldn't really find anyone that had a definitive answer. Should it be a single business capability, or should it be part of a business capability stitched together? Was a microservice as small as a Lambda, or was it bigger than that? What was too small for a microservice? Should it perform a single method, or would this be too much? should it do a single capability, or should it stitch a handful of capabilities together within one service? One thing that we can be sure about, though, is that multiple business functions that are coupled tightly together is a monolith. And this is not where we wanted to be. We wanted to chip away our monolith into multiple pieces. So we started planning. And some of this went really well. We planned for consistent tooling, and we started to build out consistent tooling before we began our migration. We started to plan how we wanted our application metrics. And again, we built this into our tooling, into our abstractions, so that regardless of who and when a service was being built, it had consistency around service health, around CPU usage. We wanted good tracing. We were very much aware of the fact that distributed systems are very difficult to debug. So we wanted to make sure that out of the box, we could trace a request across multiple services through logs and evaluate the success of a trace in X-ray. And most importantly, we wanted to be in a position where we could continuously deliver. Gone were the days of hours for builds to occur and us not being able to release during peak traffic and not being able to release on a Friday due to the risks of a weekend. We wanted to be able to release at any time. We wanted to be able to innovate and move quickly again. And we had to be event-driven, and we were. We picked Kafka as our event bus, and we set that up so that it was built into our tooling and into our abstractions. Why? Well, because it helped our engineers who are adopting all this new tech to do it in a uniform manner. They could start consuming events and producing events within minutes of creating a new repository rather than hours. And event-driven really is key to our success there. It inverted the communication flows of services so that services would consume and behave based on what they're consuming, rather than having to point-to-point communicate with each other. And that allowed us to begin building. So we began building, and we were moving really fast. And this was towards the end of last year, Q4. We were moving at really good pace, and it was a breath of fresh air. Certainly, from my experience, I hadn't moved that fast at Flyt, and there's lots of other engineers who are really pleased at the rate that we're building. We had 4 teams concurrently working on a migration, and they weren't stepping on each other's toes. For the first time, it seemed. There wasn't too much dependency between teams. Teams were autonomous enough to move forward. It wasn't too chaotic. And actually, within a number of weeks, we were able to serve a percentage of production traffic through our microservice architecture. And at this point, we were really pleased. Like, we'd proven the future. We were ready to undertake the rest of this migration. And we thought, well, we've taken the first 80%, Pareto's principle. Now, let's smash the final 20. And it had been relatively pain-free, which was great. There hadn't been too many snagging points thus far. And we got a bit excited, and we got quite confident. And we started to celebrate just maybe a little bit too early. And then we ran into some serious growing pains. We'd underestimated quite a lot. We'd underestimated what it takes to test effectively in a service-oriented architecture. Testing in a service-oriented architecture is different because you have boundary concerns. You can't just write unit tests within your service because you can't necessarily ensure that all of your services communicate or link up together in an event flow. We'd underestimated the complexity of our tech choices. We'd gone from being a company that was predominantly PHP in our PHP monolith to moving to Golang. And in addition to moving to Golang, which only a handful of engineers had experience with, we also adopted Kafka as our event bus. And we believed that Kafka was the right choice at the time. And we started to run into some scalability issues. And those scalability issues stemmed from the fact that when we adopted Kafka, we didn't really understand how it would play into our scalability. We assumed from going from a PHP monolith that was horizontally scalable, but a bit brittle, to Golang, which is an incredibly fast language by comparison, would be infinitely more scalable. But what we hadn't really understood is the nuances of Kafka that would mean that scaling dynamically was actually going to be really hard. And we had really underestimated what the size of our services should be. Back again, size. How big should our services be? We'd started to decompose, We started to plan what our capabilities should look like in this service-oriented architecture, and we'd split things out in an extremely granular fashion. There were services here and services there. They were all over the place, but this felt right. We wanted microservices, not macro services. We didn't want a monolith. We wanted small. Small is better. And then there was service ownership. And service ownership was tough. We'd underestimated the fact that when you introduce lots of services, you're later going to need to be in a position to actually own them. And over time, we introduced dozens of services, but they need to be maintained. They need to be updated. You need security fixes and bug fixes. More services was challenging. And that's not all. Training was tough. We'd introduced a new language, a new stack. It was difficult, and we didn't really appreciate that. And upskilling was proving more challenging than first anticipated. We had individuals come in to do workshops, but over time, it was still taking us a lot of time to get individuals familiar with this big shift from PHP to Go with Kafka. Onboarding had become much more difficult. Why? Well, we hadn't got rid of our monolith yet, as we disclosed earlier. Our monolith was still being decomposed. And introducing new engineers who may have been hired from a PHP background, or a Go background, or a TypeScript background, into a world where we're doing a bit of everything because we're mid-migration, is really hard. Really hard. And the biggest thing that we underestimated was the mindset shift. Building microservices in an event-driven architecture is a big shift. You've got to design and architect in a completely different manner to how you would just flesh out a monolith application. You have to cater for the fact that your services are going to be in an eventually consistent environment. They're not always going to have the information in real time. And our engineers weren't really very used to that. I certainly wasn't. And you need to build with more focus on failure, because you can't have one service fall down and it impact a whole cluster of services and it take the business offline. Otherwise, you've coupled everything too closely together. You're not really reaping any of the rewards. But that's a bit of a mindset shift. And end-to-end responsibility was tough. Why? Well, engineers had been accustomed to deploying, to a platform that was mature. And they weren't owning the platform, they were just owning the code that they deployed. And even then, they were only really owning the tasks until they met production. The difference being now that we were deploying services and then owning those services. So you would design, architect, build, own and maintain a service. And that's a big shift. We were spending a lot of time on new problems that we hadn't anticipated, problems that we really hadn't forecasted. And some of them were really tough, requiring a lot of rework from our side. And we really didn't know if the solutions we were now making to solve the previous solutions that were actually problems were right. How did we? We didn't really have the expertise. We were still learning as we went. But we have learned a lot already. We'd introduced tech that we didn't really fully understand, and Kafka was a big piece of that. We hadn't really understood it enough to adopt it at the same time as we adopted everything else. And we can say confidently now that 90% of its usage within our company is right. But we have had growing pains where it just hasn't really fit properly. We've made changes to our product capability throughout our migration. We thought we understood the way that our product works for our customers, but obviously from a monolith that's grown over 6 years, there are nuances in there and we didn't have perfect knowledge. We tried to simplify our product in ways that actually created more problems further down the line. And we couldn't expect an engineer's mindset to shift overnight, or for them to be fully productive from day one. And it's not to say that we ever expected that, but we never really anticipated what that uptick would look like. And even now, I think lots of us are still adopting this new way of working because we hadn't been accustomed to it before. And we've started to experience that too much autonomy without standards introduces a lot of unforeseen problems. Without standards, teams and individuals are able to work in a way that helps them move quickly, which is great. It's what we set out for. But then the maintainability and the ownership of non-standard work makes a lot of friction when individuals jump onto something they didn't build. And we identified, and this is really important, we identified that decomposing further than necessary has significant costs and introduced significant risk. We ran into issues quite early on where we had race conditions because we'd split our services into such a granular fashion that other services were depending on things that weren't quite there yet. And the whole eventually consistent part was really causing us a lot of problems. And these problems would have been avoided had we not decomposed so far, had we allowed multiple services actually to be built as a coupled service together. We tried to be really granular, and for the most part it was working, but certainly there were questionable moments where perhaps we'd done too much. Perhaps we had decomposed to the point where we'd over-optimized. So we're talking about size again, and is smaller really better? More service actually means a higher cost of implementation because they take longer to build and stitch together. There's a higher cost of ownership. Why? Well, you've got to maintain them. You've got to keep them up to date. You've got to keep them online. And obviously there's also a cost in terms of resource capacity as well. There's also a higher cost to troubleshoot and resolve. The more services that are interlinked together for any given capability or any behavior means that it takes longer for an engineer to diagnose a problem. It will sit somewhere in a chain of events that can occur, and where it happens is much harder to decipher than if it was just in one service or in a monolith. We've been guilty of premature optimization, and with the best, it was all with well intent, but it had caused us problems. Those of you who are listening, have you experienced premature optimization, either inside of microservices or perhaps just within a monolith? I certainly have, and I'm certainly guilty of it. Sometimes you see a potential bottleneck and you attempt to predict that that bottleneck is going to happen sooner rather than later. So you spend time and you're in a position where you try and optimize now to save the future. And then that future date never comes. So you've actually spent a lot of time for no purpose at all. I see a couple of individuals in answering with, nope, what's that? Well, what is premature optimization? Premature optimization is optimizing for a problem that's not yet here. It's a hypothetical. For instance, conceptually, we think that there could be a bottleneck with our database when we have too much traffic. We're not sure when we're going to have that much traffic. We're going to optimize now so that we're ready for it later. But if later never comes, we've wasted our time. Moving on. Eventually at Flyt, we started to feel like we had some maturity. We started to overcome these growing pains, and that was good. The tooling started to feel consistent, and we had less frequent issues, and this was really good. Culture had begun to improve, engineers were starting to feel happy, fulfilled, rewarded, and the company was reaping the rewards too. We're able to move fast again. We had some faith in the ability to deploy on a Friday at peak times, and this was something we'd been longing for. It didn't last. We ran into some fires, but they were much smaller than before. The fires that we used to have with our monolith would take days or even longer to resolve, but now we had fires that were actually being able to be resolved very quickly. We did run into further challenges though, and one of these is that consistency is actually really hard, and without it, it's really hard to move fast. If you have inconsistencies across teams, then moving between multiple services that are owned by different teams is challenging. The flip side of that is too many standards stifles the ability to move fast, and perhaps we hadn't quite got the balance right yet. We had a lack of site reliability engineering principles at Flyt.
And that had meant that we were really struggling to trust the long-term success of our new services. We had application metrics, but not business ones. And we didn't have appropriate alerting in place to know when things went wrong. We could only respond as quickly as our customer would tell us that things were not working. And we'd identified the fact that autonomy allows teams to self-isolate. And not self-isolate from Corona, they're self-isolating from each other. They're in a position where they're so autonomous that they no longer need to work out loud. They can work away at their tasks. And this creates a void of knowledge and communication. We encountered teams that were doing very similar things, and neither of them knew that each other were doing that. And that meant there was a lot of duplicate work. So despite the fact that both teams were moving quickly, they weren't necessarily moving efficiently. And we've realized that there is the knowledge of how dozens of services stitched together is actually really difficult to overcome. It's easy for someone to understand roughly how behaviors work within a monolith. They can click between definitions of a class and functions. But knowing how dozens of microservices stitched together for one behavior is really hard. It's hard to document, and it's hard to keep the documentation up to date because teams have autonomy. They can pull services in and out as they require. And diagrams are hard to update and actually really hard to understand. If we were starting again, well, what would we do differently? Certainly from my perspective, I would ensure that you avoid changing business capabilities during a migration. It introduces loads of risk that we could have otherwise avoided. We should have stuck to our guns and stuck to what we knew and optimized later and changed our behaviors iteratively. We should have kept the new tech to a minimum and again, introduced it iteratively. We went from a PHP monolith to planning what our perfect architecture looked like. And we picked all the tools off the shelf, put them in a bucket and said, this is what it's going to be. And actually, lots of those were untested and untried. Things like Garden and Kafka, we had no real experience with. And if we'd have picked them off one by one, we could have really evaluated them independently and decided whether or not they were the future of our organization or not. And the most important thing, I think, is to expect short-term trade-offs. It's inevitably going to be 2 steps forward and 1 step back. And that's fine. That's what engineering is like. We are in a position where we are reaping the benefits. It just means that we are running into problems as we go. So what's next for Flyt? Well, to overcome some of the challenges that are aforementioned, we're going to attempt to adopt some inner source processes. So teams are empowered to work on other teams' services using open source style standards, but within the comfort of our own company and our own company standards. We're looking to level up our SRE standards so that we're in a position where we have a lot more faith and trust in the services that we deploy. And we're ready for a post-COVID world. What does this really mean? Well, if we hadn't migrated from a monolith to microservices in the last 6 or 7 months, we would not be in a position right now to be able to move quickly in these weird and uncertain times. And the hospitality sector has been shaken up overnight, and it certainly won't go back to the way it was. It's unlikely that bricks and mortar restaurants will go back to normal this year, and there'll be a heavy reliance on takeaway in the market. And we're able to move quite fast now because of the fact that we have this service-oriented architecture. That wouldn't be the case if we were still battling our monolith. Anyway, I'm sure you've seen and heard enough of me for today, and I'm probably out of time. So my last points before any Q&A is things to consider. And that is to leverage the benefits of your monolith for as long as possible. One size never fits all. And that means that the service sizes for your organization might be different to ours. Certainly, the right size service at Flyt is different to the right size service at Uber. And I suspect that that's actually true for a great deal. We can learn a lot from big companies like Uber and Netflix. But at the same time, the shoes don't always fit us. We can't just adopt everything blindly. We can learn a lot by spectating and adopting what they do slowly and iteratively, but we certainly shouldn't take it as the only way and the only course. And lastly, it's really important to know that no big company started with microservices. Companies like eBay took a long time to move from a monolith to microservice architecture. Others like Monzo actually transitioned within 18 months. But that's not to say that any of those companies started with a microservice architecture.
they leveraged that monolith until they need to decompose because they'd outgrown it. And we should all be doing the same. We should be leveraging that monolith for as long as possible until the pain is too much, and then we should decompose and decompose progressively. I'd like to thank Unsplash for the stock imagery that you've seen riddled throughout this talk. Most of it not applicable to my points, but it makes the slides more vibrant. And I'd like to say thanks for listening. I've got a feedback link that I'm going to share into the Zoom as well. I'd really appreciate feedback from everyone who's listened today. This has been my first talk. I will, in the feedback survey, is the opportunity to leave your name. It's purely optional. But next week, Rory will be pulling out a name out of the hat, and I'll be awarding someone a £50 Amazon voucher for their contributions. So hopefully that will encourage you to provide some feedback. If you'd like to reach out to me personally, you can via my email address or the LinkedIn, and I'll share that afterwards as well. But for now, let's move on to the Q&A.
Right, I'm going to jump in with Duncan's question first. You mentioned Kafka being an obstacle when it came to scaling a newly built environment. What was the bottleneck? Did you replace it with an alternative? So the bottleneck that we identified with Kafka actually really only impacted, or has thus far impacted, one of our services. And that is when you set up a Kafka topic, you have to set up a number of partitions for that topic. And then you have services, you have your service that consumes from those partitions. And as they act each event, they move on to the next one. So if your topic has 100 events on it, but you only have 3 partitions, you can only consume 3 events at a time. If you want to increase your partitions, you can, but obviously there is resource overhead for that. And doing it dynamically means that you need to go through a situation of rebalancing which events sit on which partition. And we'd encountered a situation where, frankly, we couldn't pull off events from our partitions quick enough. So as a short-term solution, we had to add an awful lot of partitions, causing us an awful lot of resource overhead, costing us an awful lot of money. The current alternative is we're going to move towards SNS and SQS for events that don't need to be ordered. And that means that we can pull off as aggressively as we require. Hope that answers your question. If it doesn't, please reach out to me afterwards. How many services does Flyt currently run in production? Upvoted by Felipe, an ex-Flyt employee. That's a really good question. It's north of 30 now, I believe. It's really hard to say. Lots of teams working on lots of services. I would say about 70 or 80 have made it into production over 6 or 7 months, and lots have been torn down. But certainly, we're in the realms of north of 30 in prod. And that number is continuing to grow, but certainly a lot slower than it was historically. The transition between monolith and microservices is often tough and time-consuming. How did you manage expectations with your stakeholders? A really good question, and something that Flyt's really good for is that from the top down, this was an exercise agreed with by the exec team to be undertaken effectively as a time box exercise. We began in Q4 at the beginning, and the intent was for us to be done within 3 months, and we'd cut scope and cut corners where possible in order to achieve it. Realistically, that wasn't possible, but we certainly were able to communicate where we'd got to and the benefits. The migration still is ongoing. We aren't there yet, but we, I would say now, are at least north of 80% of the way there in terms of actual traffic and actual capabilities. It will all be ongoing, and there will inevitably always be remnants of that monolith, but we've always had the buy-in for the stakeholders. So it's really difficult to answer that question with any confidence in how you would do that. My advice would be to chip off a service at a time and not anticipate doing a big bang or waterfall approach. Taking a service at a time should mean that as other business requirements and demand comes in, you're able to move back and forth, and you can manage the expectations of your stakeholders individually. Was there a shift in testing strategy during the transition? There has been. It's not quite there yet. Historically, lots of unit and integration tests were written. We introduced the concept of a capability test, which would test end to end across multiple services, and they've been adopted, but in no way, shape, or form in enough of a granular fashion to provide all of the benefits, but they've certainly stopped us breaking production in numerous instances. There's inevitably going to be better testing to come, and it's something that we still need to improve. But certainly now we're bolstering not just unit and integration tests, but capability tests that span a whole business flow, which is proving really beneficial. And without it, we really wouldn't have trust in the boundaries between our services. I'm not sure how I see the next questions. If there are any, maybe there are not any. How to handle distributed transaction problems. This is something we're running into right now. I don't have the answer. We're still ongoing. It's something that has plagued us even as frequently as this week. So if anyone does have an answer, we would appreciate you reaching out.
Nigel's just asked a question in the chat, Aden, if you want to look at that on the Zoom chat.
Sure. Let me just work out how to pull that up.
How would you go about persuading management and senior management who have been nursing a monolith for 30+ years that they have been doing it wrong? Well, to be honest with you, chances are they haven't been doing it wrong. They've been doing it in the best way for the organization at the time, but eventually stubbornness and old habits probably mean that innovation and a radical change in thinking isn't quite ready yet. I would probably suggest that an exercise around pulling off components where things are particularly problematic is the best start. I don't think that anyone with a 30-year monolith is going to be in a position to pitch to overhaul it overnight. And instead, I would suggest to start pulling out piece by piece the areas that are causing the biggest bottleneck, whether that is the ability to iterate and make change, or whether that's areas of big risk or areas that are being frequently developed and deployed.
Thank you.
Would you use Golang if you had to do it again, and why? Certainly for the type of work that Flyt's doing, I think that lots of different languages would be applicable. I think that we don't yet fully reap the benefits of Golang. We don't do anywhere near enough parallelized processing. And lots of the work that Flyt does in terms of communicating between third parties via HTTP and point of sale devices don't reap the rewards of a high throughput language. But that's not to say that I would go back to PHP for these types of problems. So really ambiguous answer from me. I think Go with Kafka is actually a fantastic choice, and I wouldn't consider doing PHP with Kafka. But if you were fleshing out a new startup, I would say that jumping in and going into microservices with Go is certainly premature and will inevitably slow you down rather than speed you up. I can tick the little things. Thank you for the comment. Just clicking through. How do you define event-driven? How do you differentiate from request-driven? It sounds like maybe you're just describing the absence of active coordination. So the majority of Flyt's behaviors are event-driven in the fact that we raise events based on state change. So for instance, with the flow that we have around ordering, when an order is received, we'd have an associated event. We try to avoid that point-to-point contact there. And as state changes happen, we raise further events and listen to those. I'm not sure if that answers your question, but please reach out to me afterwards and I'll be more than happy to discuss with you further. Can't see your name there, it's anonymous. How did you decide what part of the monolith to pull out as a microservice first? That's a really good question. And actually, we made the mistake initially of trying to pull out more than one piece at the same time and realized that it was slowing us down. Flyt has probably about half a dozen different pieces of like core functionality or core business capabilities that we provide. And we tried to undertake 3 almost simultaneously. And that quickly became 2. And then we moved all of the focus onto 1, because actually we diluted our teams across too many things and it was slowing us down. And actually we wanted to prove that moving towards a microservice architecture was beneficial sooner rather than later. As one of the questions alluded to earlier, there are business stakeholders that we have to convey our success and shortcomings to, and doing that successfully for one business capability first is important. The capability that we ended up pulling out first actually was the one that had the highest throughput of our traffic. It was our most critical, and it was also the one that was being impacted most by change. So in our monolith, making changes to that behavior was difficult, and making changes to that behavior was introducing risk to other behaviors. By pulling it out, we could at least segment some of that risk into our new environment and test it out. And it was also the most well understood domain. It had been around for 5 or 6 years versus some of the new ones that were kind of still being fleshed out. And the knowledge piece there is key. Making change when you don't have perfect knowledge is really hard. It introduces a lot of risk and uncertainty. The more perfect your knowledge, although it will never be perfect, the easier it is to make predictions as to where you want to land. Have you had a problem with cost overruns due to lots of microservices? I can't comment on this personally, but I know that our services, so our costs for certain things have gone up dramatically in certain areas. As I alluded to earlier around the partitions with Kafka, that increased cost significantly. And actually picking Kafka as our event bus had far greater costs than had we gone down the path of SQS and SNS. So that's something that we now have to, I guess, bear the brunt of. But I wouldn't say that the cost overruns are things that hadn't been too well considered, but it's really hard to predict, not having full oversight of the budgets right now. Why not keep the monolith and learn by adding additional services to our microservices? An API gateway in front could have load balance the requests. So I think what's being suggested here is rather than take the capabilities that we already had, we would instead begin adding additional capabilities as microservices while keeping our monolith. And this would make sense, except for the fact that we were having to make a lot of changes to our existing capabilities rather than create new ones. If we were creating just new ones, we could have certainly explored in that situation. But unfortunately, we're actually spend the majority of our time tweaking and changing a handful of business capabilities that have existed for a really long time. And creating a way of like load balancing the requests with a gateway there, actually really not particularly feasible. But one of the things that we did do, and I think is valuable and relevant to this question, is effectively we managed to route pieces of behavior of our monolith to microservices to test them as we went. There was no big bang. We created additional services in microservices that replicated our monolith, and we routed them through our gateway to trial it out. And when it didn't work, which inevitably it didn't, there's no home runs here, we could route them back to the monolith, and the impact to our production traffic was very minimal. And we flip-flopped between switching between monolith and microservices every day, every week, until we really perfected it. And we did that capability by capability, and actually by restaurant partner one at a time, to ensure that for each restaurant partner we worked with, we hadn't introduced loads of regression by moving from our old monolith into new microservices. I already answered the testing strategy one. What do you use for your capability testing? We have basically we have a hand-built library internally for capability with Mountbank and as a proxy for proxying external and internal requests. I think there are some other Go packages that are involved with that, but certainly it's handcrafted. we haven't found anything suitable off of the shelf for us. I think if we had, we might have had a greater uptake for it, but it's really hard to say. Hindsight's a wonderful thing. What do I think about Rust? Well, I have no opinion on Rust. I've actually never explored it. So I can't really answer that, I'm afraid.
Great. That seems like all the questions then. As we said, oh no, sorry, one more.
Do you use a specific framework for building microservices in Go? That is a really good question, and we do, but it's an internal one that we built out before we undertook our migration. And there are lots of frameworks out there, and I'm sure lots of them have their merits. Some of them are quite fat, maybe a bit too fat for microservices, and some of them are very thin. We certainly introduced a high cost of ownership by building out our own tooling, but it seems to be working for us right now. Unfortunately, we aren't able to share that framework that underpins all of our microservices. It's internal only, at least at the moment.
Great. Well, if that's it, first of all, thank you very much, Aden, for a great talk. We'll post his contact details, as was mentioned, on the event page. So anything else that crops up, drop a message. And yeah, we'll send out the feedback as well, the feedback link sometime today. So over the weekend, if you've got a chance to have a look at that, that'd be great. And yeah, provide any feedback would be greatly appreciated. Otherwise, hope everyone has a good long weekend. Enjoy the sun if you can. And I think that's all. Yeah, all happy, Aden?
Thank you very much, everyone, for attending.
Cool. Cheers, guys. Have a good weekend. Bye.
Great stuff. Bye-bye.
Thank you.